Students, let us solve this Irodov problem 1.20. This is a very good problem with a technical language. A radius vector of a particle varies with time t h. This is a radius vector and this equation is not given in a scalar form. This equation is given in vector form. Vector r equal to vector a into t minus alpha t square. So, this is the equation given. Now, let me check that this is a number. Yes, sir, this is a number. So, the direction of vector r is either in the direction of vector a or in the opposite direction of vector a. And in the question, it is given that vector a is a constant vector. So, I assume that this is the direction of vector a. So, the position vector is either in this direction or in the opposite to this direction. So, this is a motion along a line. Okay. Alpha is a positive factor. Yes, sir, alpha is a positive factor. Now, at t equal to 0, vector r is 0. So, this is the initial position. At t equal to 0, this position is 0. So, let me call it x. Okay. The first part is the velocity v and the acceleration w of the particle as function of time. So, to calculate the equation of velocity, we have to differentiate that. The position vector will become velocity vector when we differentiate vector r with respect to time. So, this is a constant, we don't have to worry about this. And the differentiation of time is 1 and differentiation of t square is 2t. So, it is 2 alpha t. Okay, what is this? The direction of velocity is also either in the direction of vector A or in the opposite direction of vector A. So, velocity is also either along this line or in the opposite direction. Now, if you further differentiate this velocity, it will become acceleration. So, in the question, acceleration is represented by symbol W. So, W vector equal to, this is a constant, vector A. The differentiation of this is 0 and differentiation of t is 1. So, it is minus 2 alpha. Oh, so we can write is minus 2 alpha into vector A. It means that acceleration is constant but in the opposite direction of vector A. So, the acceleration of particle is always in this direction and have magnitude 2 alpha a. Yes, this is the acceleration. Okay. So, the first equation of v is vector a into 1 minus 2 alpha t and the acceleration minus 2 vector a, minus 2 alpha vector a. Now, initially, what is the velocity? So, if you put t equal to 0, the velocity is vector a. Vector a means in this direction and the magnitude of velocity, the magnitude of initial velocity is a. Okay. So, velocity is in this direction and acceleration is in opposite direction. So, what is the motion? The particle will go in plus a direction up to certain point and then particle will return. And then particle will return. Okay. Now, this is the position when velocity becomes 0. We can calculate the time. So, when v becomes 0, this part becomes 0. So, the time is 1 divided by 2 alpha. So, this time is 1 divided by 2 alpha. Now, I have to calculate the time interval delta t taken by the particle to return to the initial points and the distance s covered during that time. So, I have to calculate the time when particle return to its initial position. So, how much time it will take to go from this point to this point? 1 by 2 alpha. then the same time will be taken from this point to initial point. So the total time is 1 by 2 alpha plus 1 by 2 alpha, and it is equal to 1 by alpha. The time taken by the particle to return its initial point is 1 by alpha. Okay. Now the distance traveled. We know that from kinematics this distance is the forward distance, or we call this distance as stopping distance. The formula of a stopping distance is u square divided by 2 into acceleration a. So what is the initial velocity? Initial velocity is a. So it is a square, okay, divided by 2 into acceleration. This is the acceleration, 2 alpha a. So this is a divided by 4 alpha. So this is the stopping distance. So the total distance covered. So total distance covered is this distance and this distance. Both are equal. So the total distance traveled is a divided by 4 alpha plus a divided by 4 alpha, and it is equal to a divided by 2 alpha. Yes. Now, so we have to calculate these two parts. So this is the solution. Now the question is very simple. This is a question of stopping distance, but the language is so vast. It is given in vector form, so it look like a very complicated question, but it is a regular question which is given in any sheet of any coaching.